Two advanced technologies, one fundamental question. How do pellet 3D printing and filament 3D printing compare? In this video, we'll break down the differences and help you decide which method is best for your manufacturing needs. Both fused granulate fabrication and fused filament fabrication are forms of material extrusion additive manufacturing, but they differ in the materials used in their key applications. FGF utilizes materials in pellets or granules, while FFF uses spools of filament. Both technologies begin when materials are dried and delivered to an extruder. A filament extruder generally pulls material from the spool using a tensioned, motorized system that then pushes the filament into a hot end of the extruder. Within the hot end, heat is transferred from the outer surface to the inner core of the filament until the material eventually gets hot enough to be extruded through the nozzle. In contrast, a pellet extruder consists of a screw and barrel. As that screw rotates, pellets are mixed and heated and transported through the extruder, creating a more uniform melt. The material is compressed as the screw pressure builds, forcing the material through the nozzle at a much faster rate than FFF. One of the largest advantages with fused granulate fabrication is the wide range of materials users have access to. There are far more materials available in pellet form, with many of these materials not only being more accessible, but also being better engineered for specific applications. At JuggerBot 3D, our Tradesman Series P344 is capable of printing materials across the entire polymer pyramid, including both semicrystalline and amorphous thermoplastics at each level of the hierarchy: commodity, engineering grade, and high performance. We've also demonstrated the ability to reliably process reinforced materials with fiber loading contents from 5% all the way up through 66%, including bio-based materials and even materials with more exotic additives. Pellets are also significantly cheaper than filament, as much as 90% less expensive. FFF, on the other hand, tends to be a little more expensive due to the additional processing required to turn pellets into filaments. And for smaller projects, the costs may be manageable, but they can definitely add up for larger scale production. In terms of fine details, FFF generally has the upper hand. Since filament extruders use smaller nozzles, they can achieve finer resolutions, thinner walls, and smaller features. FFF prints can also include breakaway or soluble supports for bridging and overhangs depending on the printer configuration, allowing operators to make more complex geometries. By contrast, FGF is better suited for larger, bulkier prints, such as tooling and end-use parts. These extruded beads tend to be wider and taller, focusing on speed and efficiency for large format manufacturing. In cases where smooth surfaces or more precise features are required, FGF can be finished by hand or on a CNC machine. There are multiple factors that play a role in 3D printing production speeds, including throughput and layer time. FFF extruders generally max out around 1 pound per hour. FGF extruders are largely designed for a specific machine platform, with throughput ranging from tens of pounds per hour to hundreds of pounds per hour. Layer time is a variable that tells operators how fast the material will cool down during the 3D printing process. The minimum layer time refers to the amount of time required for the previous layer to cool enough to maintain its shape, whereas the maximum layer time refers to the amount of time that can pass before the previous layer has cooled too much and insufficiently bonds to the next layer. It's important to accurately incorporate layer time as it directly correlates to a print's dimensional quality, the print's performance, maximum part size, and cycle time. FFF printers generally require actively heated chambers to make sizable parts, combating the maximum layer time, whereas most FGF printer cycle times are extended due to the minimum layer times. FFF dominates in areas of prototyping and product development. It can also be a great tool for small batch production when permitting materials are available, especially for designs with finer definition or complex geometries. FGF is revolutionizing manufacturing where large, durable parts are required. Aerospace, defense, and construction industries are great examples, using FGF printing for jigs and fixtures, production tooling, and end-use parts. So, how do you choose between FGF and FFF? It all comes down to your needs. If you need fine detail and versatility for smaller projects, FFF is the right choice. But if you're focused on large format, cost-effective production, and materials matter, FGF is your go-to technology. We create these videos in hopes to build an understanding, layer by layer, of the impact that these systems can have on the needs not currently met by traditional production. Thanks for watching. If you're ready to learn how large format 3D printing can benefit your business, visit our website or contact us today for a consultation.